Students, let us solve this Erodov problem, problem number 1.24. A radius vector of a point A relative to the origin varies with time th. The radius vector of a point is given as at I cap minus bt square j cap. So, the radius vector has a component in x direction as well as y direction. Now, to consider this problem, I calculate x direction in different column and y direction in different column. So x is given as a into t and y is given as minus b t square. Okay, where a and b are positive constants and I cap and j cap are the unit vectors of the x and y axis. Find first the equation of the point's trajectory yx. Plot this function. So first I have to find the equation of trajectory. So how to find the equation of trajectory? So from this equation I can write time t equal to x divided by a. Now this time I am going to put in this equation. So y equal to minus b into t square. T square means x by a square. So it comes out y equal to minus bx square divided by a square. So this is the equation of trajectory. So the first answer is the equation of point trajectory is this. Now we have to plot this function. So the power of y is 1 and the power of x square is 2. So the plot is parabola. Okay. And this parabola passes through the origin. Now, how to plot this parabola? See, the power of y is 1 and the power of x is 2. So, the parabola is either this way or this way. Now, b and a are positive constant. So, this term is minus. So, the parabola should be inverted. So, this is the actual plot of y equal to minus bx square by a square. This is the plot. This plot is the correct one. Because of minus, this parabola is inverted. So, this is the first answer. Now, there are remaining parts in this question. Let me see what are those. So, the time dependence of the velocity v and acceleration w vector as well as the moduli of these quantities. So, we have to calculate velocity vector and acceleration vector as well as their magnitude. If I differentiate this position vector, it gives velocity, but velocity in x direction. So, velocity in x direction is a. If I further differentiate this velocity, this gives acceleration in x direction. So, acceleration in x direction equal to 0. Differentiation of a constant is 0. If we differentiate this y, it gives velocity in y direction. So, velocity in y direction equal to minus 2bt. If I further differentiate this velocity, this gives acceleration in y direction. So acceleration in minus y direction is minus 2b. So acceleration is constant and only in y direction. There is no acceleration in x direction. Let me write this velocity and acceleration in vector form. So velocity in vector form is this I cap. So a I cap and this j cap minus 2bt j cap. What is the modulus of this velocity? Magnitude of this velocity will come out under root a square a square of this part and a square of this part plus 4b square t square. What is the acceleration in vector form? Acceleration is written as w vector. So acceleration vector equal to, there is no acceleration in x direction, only acceleration in y direction. So minus 2b j cap. What is the magnitude of this acceleration? It should be 2b. So in second part, the velocity vector is this, magnitude of velocity vector is this, acceleration vector is this, and this is the magnitude of acceleration vector. Now in part sheet, the time dependence of the angle alpha between the vector w and vector v. We have to find the angle between acceleration and velocity vector. So how can we find it? To find the angle, I use this term. Now let me see the direction of acceleration and direction of velocity. So this is the acceleration. So acceleration is in this direction. So this is the direction of acceleration. What is the direction of velocity? Velocity have a component in x-axis. So this is the component of velocity a, and this is the component of velocity in y-axis. So this is the part of velocity which is 2bt. So what is the total velocity? To find the total velocity, we have to add these two parts in vector form. So this diagonal represents the velocity. So this is the velocity vector v. Now this is the acceleration vector and this is the velocity vector. So this is the angle alpha between velocity and acceleration. So we have to find this angle alpha. Now this is the right angle triangle. Tan alpha should be equal to this length divided by this length. This length is a and this length is 2bt. So tan alpha should be equal to this length a divided by this length 2bt. Now this alpha depends on time. As time increases, alpha decreases. So the third answer is tan alpha equal to a divided by 2bt. Fourth part, the mean velocity vector averaged over the first t second of motion and the modulus of this vector. So in part D, I have to calculate the average velocity vector. So how to calculate average velocity? So the definition of average velocity is displacement by time. So the average velocity vector equals to displacement vector divided by time. What is the displacement vector? It should be equal to at I cap minus bt square j cap divided by time. So this will come out a I cap minus bt j cap. So this is the average velocity vector. We have to calculate the modulus of this vector. So modulus of average velocity vector is equal to under root a square of x part a square and a square of b part. So b square t square. So this is the answer of part D. So in this equation, there are two parts, one in x direction and other in y direction. By differentiating this position vector, I get the velocity in x direction, and further differentiating with respect to time, I get acceleration in x direction. From this equation, after differentiating with respect to time, I get the velocity in y direction, and after further differentiation, I get acceleration in y direction, which is a constant. So this is the way to find the different quantities asked in the question.